Alright class, welcome back. Video 4. Just a quick word on the last step. It says evaluate. It says the answer is correctly given to 3 significant figures and is close to an estimated value of 75 grams. Well, what is this 75 grams all about? It's saying, well, to make sure that your answer is right, you'd look back and estimate without doing the calculations that oxygen gas would be about 30 grams per mole, and 2.5 times 30 is 75. It's so simple that it's kind of hard. The point is, on harder problems, you're going to need to evaluate and see if you're close to the mark. Speaking of harder problems, let's move on to the next sample problem, which is sample problem I. But before we do that, let's read this little paragraph right here. To convert a known mass of a compound in grams, so it's basically to go from grams to an amount in moles, the mass must be divided by the molar mass. Or you can invert the molar mass and multiply it so the units are easily cancelled. So it's saying mass in grams. If you're going from mass in grams to the amount of moles, you can just flip the molar mass upside down. And so you get 1 over molar mass grams per mole. You'll find out the amount in moles. Why? Because grams will cancel out and all you've got left is moles. Sweet. Let's move on to sample problem I. This one's a bit of a bear, but I know you can do it, and we can do it together. Ibuprofen, C13H18O2, is the active ingredient in many non-prescription pain relievers. Its molar mass is 206.31 grams per mole. Question A. If the tablets in a bottle contain a total of 33 grams of ibuprofen, how many moles of ibuprofen are in the bottle? Okay, so start right away by writing number I for sample problem number I, and start writing down the givens. Gives you the formula. It gives you the molar mass. Okay, and then the unknowns. The unknowns for number 1 is basically how many moles of ibuprofen are in 33 grams. Okay, and then unknown number 2, let's read it. How many molecules of ibuprofen are in the bottle? Okay. Write this down with me. And the third question is, what is the total mass in grams of carbon in 33 grams of ibuprofen? All right. So we'll just do one step at a time. First, how many moles of C3H18O2 are in 33 grams? Well, there's a number of ways you can do this. You can go back to the previous page and check out the picture and find out. Remember this? It says this neat little illustration. You're starting with grams. All right, so you're starting with mass of compound in grams, and you want to go to number of moles, and so you're going to use the molar mass of the compound inverted. All right, so let's do that. So number 1, you'll say, I don't know, maybe you'll draw an arrow or something like this, and you'll say, okay, say 33 grams, write it out. Don't be sloppy, don't be lazy. You can use a conversion factor. And you know that there are 236.1 grams for every 1 mole. Okay, that looks kind of like what we did up here. See, 1 mole, 236 grams. Do the math, and you'll get an answer. Let's see if we can do the math together. Let's see. 33. I'm going to divide by, because I'm multiplying times 1 over something is the same as divide by, 206.31 equals 1.599. All right? Now let's do significant figures. We can only use 2 significant figures, so let's say about 1.6 moles. Okay. Let's move on. See if we got it right. All right. We're going first from grams to moles. We're going to use the similar thing we've done, grams of ibuprofen times 1 mole of ibuprofen over 206.31 equals mole of ibuprofen. Okay, looks like we're good. What about part B? Part B, it says, how many molecules of ibuprofen are in the bottle? Okay, so now we want molecules. Can we use our handy chart and find out how to get to molecules? Well, if you want the number of molecules or formula units of a compound, you're going to need the amount of moles of the compound. Well, we just figured that out, didn't we? All right, so we're going to use the amount of moles, and we're going to multiply times Avogadro's number. Pretty easy. Let's go ahead and do that. So we've already figured out that there are 1.599 moles in this compound. Just a moment.